This is the first video lecture for week number 4. Here we continue the chapter 2 differentiation. In this video lecture we study the most important, the power rule, and what do you mean by higher order derivatives. So first let's see the basic rules to find the derivatives. First rule: the derivative of a number, only number, no x here, it is always 0. So this is any number, that means real number. There is no x here. Similarly, please recall that limit of a constant is constant, whereas the derivative of a constant is 0. Limit of a constant is constant, the derivative of a constant is always 0. Next, the derivative of the identity function, please remember d by dx, this you are going to read as derivative of. So derivative of c, 0, derivative of x is always 1, that is derivative of a constant, the identity function is always 1. And this is a very important, the power rule. Derivative of the power function, you see this is the power function, x to the power r is a power function. How you read this? Derivative of x to the power r is rx r minus 1. So the power e becomes multiplier and then you subtract 1 from the power. So rx r minus 1. So these are the three important rules, basic rules. Then how you find the derivative of the sum of two functions? So derivative of f plus g is derivative of f plus derivative of g. See that you read as f prime. Please remember df, this f prime is the derivative of f, g prime is derivative of g prime. You have to read, don't you read as dash, it is f prime g prime. Similarly, the derivative of subtraction of two function means the same subtraction comes here. If it is plus, plus. If it is minus, and it is minus. And this is a very important function. You have to be very careful here. Derivative of number and function. Please remember, here we have only number. But here the number is with function. So that means there is a number and x. Here there is only number, no x. In this case, the c comes out. You see that c you take out. Then you find the derivative of f. What is the derivative of f? I can write f prime x. I will explain to you in the next slide. Check. Let's consider three rules. Find the derivative of fx is 1 upon x to the power 19, gx, another function, cube root of x square, third, x to the power pi. So f is given, I am finding f prime because you are asked to find the derivative. So f prime, that is d by dx of the function, this I can take it up, so x to the power minus 19 according to the exponent law. So then your power is minus 19. So according to the power rule, minus 19 x minus 19 minus 1. You know that from the power you have to subtract. So minus 19 minus 1 is minus 20. So minus 19 x to the power minus 20, answer. To find the second one, I write g prime x, that is d by dx of the function, this given here. So, and you know that how to write the power of x. So this is 2 divided by 3. So this number comes always down. So x to the power 2 by 3, not 3 by 2. So here the power is 2 by 3. So I use the power law. So 2 by 3 x, 2 by 3 minus 1. 2 by 3 minus 1 is minus 1 by 3, answer. Finally, for this, So look at it here, the pi is the power here, and you know that the pi is a rational number or a real number. Therefore, I can write directly pi x, x to the power pi minus 1. I just use the power law directly. So don't do any simplification here, leave it as it is. Another two function examples. One is finding the derivative of two functions. You see that in the earlier example, I gave you only one function. Now we have one function, second function plus. So derivative of the sum of two functions. See, f prime is derivative of first, derivative of second. So this 2 is out, I take out and I find only the derivative. See, this is c and this is fx. So c comes out, I find the derivative of only this. So when if it is only derivative of 2, it is 0. But it is number with x, therefore I take the number out, I find the derivative of only the function. So this. So here also 3 comes out, so 3 derivative of this. If it is only derivative of 3, it is 0, but 3 with x, so therefore it is not 0. So 3 out and I can write the power of x as half. So 2 as it is, I use the power law r x r minus 1, that is 5. So r x 1 minus half, that is 1 by 2 minus 1, that is minus half. So I simplify this, 6 into 2 12, 12x 5, and this minus half can be brought down, this is half. So 3 by 2 root x is the answer. So in this example, this is not the sum of what you call function. There is a subtraction, addition, and also you have a division. But note that here you have only one term in the denominator. If you have one term in the denominator, we can divide all the numerator term by that. So therefore, what I will do here is fx is equal to the first term divided by x, the second term divided by x, third term divided by x. See, I wrote here. Please remember, this is only you can do when you have a one term in the denominator. If you have x plus 1, that is 2 terms, then you cannot divide it. So x cancels, 4x, again x cancels, 3, and here the x power is half and here the power of x is 1. I bring it up, that is 1 by 2 minus 1, it is minus half. Then I find the derivative of this, 4 out. See, derivative of x. So this derivative of 3 is directly 0. I can write it, or you can show like this. And here the 2 out and the derivative of inside 1. So 4 derivative of x is 4, that is 1, 4 into 1, 1. This is 0 and 2 out. So it is rx r minus 1, that is minus half minus 1, so minus 3 by 2. So I can simplify 4 plus, this minus into my plus minus, so 4 and this 2 cancel, 4 minus x to the power 3 by 2, answer. Let's say now another example here, check. Finding the equation of the tangent line. So what are we going to do now? We are going to find the equation of the tangent line, which we have discussed in the earlier video lecture. Find the equation of the tangent line to the graph at this point. And before you find the equation of the tangent line, you need to find the slope of the tangent line. To find the slope, I have to find the derivative. So you are given fx, so 3 terms, right? We have then I find the derivative of that. So I got, so minus 4 minus 2 x to the power minus 2. So now this is the slope of the tangent line at any point x. But I am finding the equation of the tangent line at x is equal to 1. So what I will do, I will put x is equal to 1. So put x is equal to 1 here. So it becomes f prime 1. So this x is replaced by 1. So minus 4 minus 2. So minus 6. This is the slope of the tangent line at x is equal to 1. This is the slope of the tangent line at all x. So what happens now? You put now x is equal to 1 here you will get f of 1. What is f of 1? It is 2, right? So that means the line with the slope minus 6, that is this, through the point, that is you need to find the point here. This x is given 1 and this x is equal to 1, you are putting in the fx, you will get this 2. So you put x is equal to 1 here, 4 minus 4 0 plus 2 by 1, so that is 2. So you have 2. So I substitute y minus 2 in the formula equal to minus 6, x minus 1. So this you can bring it on the right. So y is equal to minus 6, x minus 1 plus 2 is the answer. Then we have very important what you call things known as higher order derivative. What we found in all the earlier example or in the basic formula, we found the first derivatives, or you can say the derivatives of first order. You see, order 1. How you denote? Y prime or f prime. How you write? In Leibniz notation, df by dx or dy by dx. This is the first derivative which we found. Then how you find the order 2 derivative? For order 2 derivative, you use the notation y double prime. See, double prime, f double prime, both are same. Or we write as d square f by dx square, not df square. Remember, d square f, no power for f. Power of f is always 1. So d square f by dx square means d square y by dx square. Say, similarly, for third order derivative, it is we write y 3 primes. See, f 3 prime. So d cube f by dx cube or d cube y by dx cube. So, but for fourth order, we don't write the prime. So, from up to 1, 2, 3, we write the primes 1 prime, 2 prime, 3 prime, but for 4 onward, we write the numbers. So, but we need to write in bracket. So, y bracket 4 means f4x. So, d4 f by dx4, that means d square y by dx4. Fifth is the same. So, only third, till third we write the prime, but otherwise we don't write the primes. So, in that case, you have to be very careful. These are the what you call prime notation, these are the order, and this is the again the derivative in the Leibniz form, or you can say in the notation. So, we will discuss in the next video lecture the examples on higher order derivatives. Let's see the examples on the higher order derivative in the next video lecture. Thank you.